So let's get started. Thank you everybody for coming out. My name is Burrows. I'm a developer in the Oklahoma City area. I do a little bit of everything. Most of my experience is in .NET. And today we're going to talk a little bit about testing and work up to integration testing with Pact. And I'll explain a little bit more what Pact is a little bit later, but it's basically a library and a framework for testing external integrations and other integrations. So for a quick overview of what I'm going to be showing today, the environment that I'm currently working on, as you see, I'm working on a Mac. Everybody seems to work on Macs anymore. .NET Core is pretty fantastic, so I'm using .NET Core. VS Code, I'm using iTerm to Git, and then I'm doing some testing with XUnit. So all of my code is going to be online. If you go to my GitHub, it's github.com/DannyBurrows. PactNet Talk, it's pinned on the repository, so if you go to my GitHub, you can actually see it there. You can download this code, you can actually run it. If you're going to attempt to run it on Linux or on Windows, you have to install a slightly different package for the Pact.net. I installed the OS X specific version here. Quick call out to docs.pact.io, where I spent a lot of time over the last week trying to figure out how to make this all work and make it all play nice. And then if you want to read up some more information about the Pact Foundation and what they do, there's a link on here as well. I'll drop a link to the slides into my GitHub in the OKC Talks channel and Slack once we're done. You can always reach me on Slack. I'm on Twitter at DannyBurrowsOKC. So let me know if you have any questions. So let's jump right in. I'm not a fan of wasting a whole lot of time, and I know everybody's busy people. So let's start. So one of the more modern movements in the .NET world is testing, integration testing, unit testing, et cetera. If you come from an open source background, this is kind of driven into how you write your code, how you build your projects, and things like that. So as I've been around in the enterprise.NET space, I've slowly seen testing be more and more integrated into what we build and what we work on a regular basis. So wanted to take a minute and kind of give you a quick introduction into what testing is, what it does for you, what it does for the systems, kind of introduce you to a couple different types of testing, talk just briefly about methodologies, and then cover some important vocabulary. And this is meant to be high level. I'm not going to go into the weeds of how to do all these different types of testing and things like that. Thought actually about doing a talk on that and decided I want to learn Pact instead. So if you want to have some conversations about this or ask some questions afterward about it, please feel free. So at its core, what is testing? So testing is essentially code that is written to test other code that we've written. So it's there's a number of ways that you can write it, but at its core, it's usually written in the same language that you write your actual code in, but that's not always the case. And this is where Pact is going to kind of come in and shine a little bit here. So there are multiple types of testing. You've got unit testing, you've got integration testing, you have user and functional acceptance testing. So unit testing is typically just a real simple, let's test a unit of code that we wrote. This usually means a specific method. Integration testing is a little bit more complicated, and then user functional testing is usually when your project is sitting in somebody's hands, they're interacting with it, they're trying to use it, trying to figure out what it's doing, if it's doing what it's supposed to and what they expected. So there are multiple methodologies to actually writing your tests. So you've got test-driven development, you've got behavior-driven development, you've got domain-driven, there's more. I mean, seriously, guys, there are like books written on this stuff. So anything that I could give you in, a 10, 15-minute talk, you can read on for weeks on end. But like I said, if you have some questions or you want to talk about it afterwards, I'm more than happy to do so. So I'm going to cover a couple important vocabulary words here, just so you guys and everybody is up to speed, because I touch on these at various points in the presentation itself. So the first thing that I want to talk about briefly is code coverage. The idea behind code coverage is essentially how much of your code is actually tested. This is usually reported in a percentage. Certain people, certain places, certain projects target a specific code coverage percentage. If you think about it like a branch of code or a branch of logic, how many of those are actually tested throughout your project? That's essentially what your code coverage metric is. We're going to talk a little bit about consumers. This is a Pact-specific terminology. A consumer is essentially a consuming body of a Pact contract, and we'll go into a little bit more detail about what that actually means. Fake, anytime that you're doing testing, you typically want to work with data. You want to actually work with data that you can control and that you can isolate. This is where faking and mocking your data can come in. From there, you've got mock and spies, which can create mocks. They're a little bit different, but almost synonymous. This is basically a way to control dependencies and things that you're injecting into your test. So let's say that you have an external dependency and you want to test, your happy path. You can mock it up to return your happy path, or if you want to test a failure, you can mock it up to test that failure. It's essentially controlling what your system that you're testing, how it interacts and how it moves through the test. Pact is obviously going to be important. We're going to talk a little bit about that. Pact is, you can think about it like a contract, right? A pact between two different people. In this case, a pact is between a consumer and a producer. So if you think about in an API, this would be the API that's actually serving the data and the service that is consuming the data, which is where the producer and the consumer terminology comes from. So producer, again, this is another Pact phrase. This is basically whichever service is providing the data is producing the data to send up to service. And then the other thing is a test runner. A test runner is essentially, could be a plugin, it could be a command line operation. Visual Studio has built-in test runners. .NET Core has built-in test runners on a command line. And these are responsible for running your tests, reporting on your tests, and making sure that you kind of understand where everything is and how everything is working. So when it comes to writing tests, there's a pretty simple methodology to doing this. You want to start basically the 3 A's, the arrange, act, assert. These are different phases of writing tests, and all tests follow some variation of this. A lot of times in your arrange phase, you build your test data, mock any interfaces, build any fakes that you need, and basically structure your test to get ready to run. The act phase is essentially calling the method or calling the service or the business logic section that you're actually going to be testing. This is when your system under test actually acts on whatever it is. And then your assertion phase. So your assertion phase is the last phase of the test, and this is where you go through and essentially say, the result from my act phase, it is exactly as I expected it, right? When you assert something is true, you expect that the result coming back is true. If you assert that something is equal to something. So there's a lot of ways to go about this, but the goal is to make sure that you're testing what is important to the business domain and the business logic on your system. So typically, you have a lot of assertions. I like to assert a lot of things, probably a little too much personally. And then from there, you can actually run some pretty cool methods to verify that any interfaces or external dependencies were called with data that you expect it to be called. And there's a few other kind of neat things you can do inside the assert phase. So I'm going to start talking about unit tests a little bit, talk a little bit about unit tests, integration tests, and integrations in general, and then we're going to jump into some code, and I'm going to show you how to actually implement Pact and how to implement the test suite and things like that. But I want to give some background on testing. So unit tests are probably your most basic and your most common form of testing. It's real simple. It typically tests individual sections of code. A lot of times, developers test specific methods on a class, and that's what they think the unit test is. That's not necessarily the case, and it's usually better to think about it as testing a specific behavior in your code. So if you're working with an object in an object-oriented language like .NET, you typically are going to test everything in the class. Now, if you have public methods, you test your public methods and things like that. But you really want to focus on a behavior, right? And the idea is that a method or a unit of code on your service or on your class or on your model is going to produce an output. It's going to produce a result that you actually want to check into. So unit tests follow the same pattern. You arrange the test, you call your method, you assert that the result is expected. And I've got a short example on here. So here's a real trivial example of a unit test. We have a public method called add, takes in 2 numbers, returns a number, right? This is pretty straightforward. And then the test method that we have to actually test this actually sets some fake data. So we arrange some fake data. We act by calling the method that we were looking at, and then we assert that our result is what we expect it to be. So unit tests can be pretty straightforward. A lot of times they're very simple in what they actually test. But there's some problems. As with everything, there are always going to be some issues and some reasons why we need to make things much more complex than what we currently have. So unit testing is notorious for creating a false sense of security. Developers tend to test the happy path, and usually the person writing the method is the one that wrote the test for it. So as a developer, when I'm sitting there, I'm just pounding away at my keyboard and trying to knock something out, like I know exactly what I want it to do. So that's what I test. And then after the fact, I think, oh, well, what if this is wrong, or what if this is wrong, right? I mean, developers and people that write tests on a regular basis, it takes them getting used to be able to kind of get yourself out of that mold. Beyond that, a unit testing is only testing one piece of functionality, right? It's only testing one small method, one small bit of your system. I don't know about what you guys write, I don't know what about, but in all the systems I've worked on, it's never one method, right? It's a service that calls a service, that calls a repository, that calls an ORM, that calls a database, that does this, and has all these steps throughout it, right? So testing the individual unit is usually good to make sure that that unit is working, but sometimes that's not enough. If you have a complicated method, you've got extensive mocking and faking of data and services and interfaces that you have to do, and you'll spend a lot of time trying to work to get your unit test to just pass, kind of with the happy path. So there's also a large focus with code coverage on unit testing, and code coverage can be kind of a dangerous metric. It's really good to target, high percentages of code coverage. 100% code coverage is ideal, in most cases that's what most people are striving for, but it can create a false sense of security. You might actually be missing some of these kind of weird paths in between services and things like that may create some problems, which is where integration tests come in. So integration tests are kind of the next extension of a unit test. An integration test focuses on a group of related methods that serve an overall business purpose. So this would be equivalent to testing a whole service or testing a repository system. But essentially, it's not quite an end-to-end test where you're testing the system from the very beginning to the very end, but you're testing kind of one section of logic on it. And I'll have an example here in just a second. One of the biggest ways to think about this is interaction between different components in your code or different sections in your code. This could be actual implementing business logic. You may actually be constructing multiple services or multiple dependencies and injecting them. There's a number of ways to go about it, but if you think about it as testing your system that serve an actual deliverable purpose, I think it actually makes a lot more sense. And the whole idea here is you skip individual testing steps and you test your outcome, right? You look at the actual outcome once you're done. So as for an integration test example, I've got some here. I've got a service, right? No. How many of you have code like this in your system, right? You've got a service that has some private methods, it has some public methods. Your service is responsible for doing work. You have to inject some dependency, right? Hopefully you're using dependency inject and have to inject some dependency into your service. You need to run a couple methods, verify input, verify user has permissions, et cetera, and then you're going to delegate your work out to your worker to go ahead and do some work. So essentially in this case, we have this method do work, belongs on this service. We verify our input, make sure that it's valid. We verify that whoever it is has permission to this. If they don't, we throw an exception, and then if everything is good, we're going to go ahead and process our job. So this is a pretty standard service method. This would be a good example of a system that you want to write both unit tests for and integration tests for, right? I've got a couple branches of logic here. If has permissions is false, I want to make sure I throw an exception. If it's true, I want to make sure that I can actually get down into the worker that's processing the job. So a quick example of a test of this would look something like this. In an integration test, I actually construct construct my worker, I'd construct my service, I'd go ahead and inject the worker. I'm going to call my method to actually do my work, and then I'm going to assert that everything is as I expect it to be. This is kind of a trivial example, but again, it follows the act, arrange, assert pattern in order to make this work. So, good example of why you write integration tests. Unit tests, again, can give you false sense of security. There are plenty of examples online. This one hits kind of close to home because I did this recently in my house. Don't ask my wife about that. She's still not happy about it. But yeah, essentially you've got these two drawers, right? Each of them work independently on their own, but when you put them together, things aren't working properly. And this is common in software, especially as you move towards integrating with external dependencies and things like that, which is where we're going to talk here in just a second. So external integrations. Modern web programming, I'm a full stack developer by trade. I do a lot of work online. I write a lot of APIs. I write a lot of front-end code. That means I have to integrate with a lot of services. You've got SaaS services, PaaS services, REST APIs, SOAP services. Everybody has a service or an interface that you can integrate with now. I mean, you look at Twitter, you look at Facebook, and things like that. Everybody's got some form of data that you want to integrate with. I like to call modern web applications the world of integrations. Here's a snapshot of one of the projects I'm currently working on. This is integrations in a quote-unquote small web application. And for context, our web application is about 3,000 lines of code. So I'm not talking about a massive system, but all of these services we're integrated with for various things, right? We've got a Stripe integration for payments, we have Twilio for sending messages, Smarty Streets instead of Google Maps for directions and address verification. We have AWS and CodeShip for CI and CD pipelines. And, we have MailChimp and analytics and on and on and on, right? And these are just the public ones, we integrate, we have multiple partners that we need to integrate with, so all of their services, all of their APIs are up, we need to integrate with them. So a lot of integrations in the modern world, and this kind of creates some problems. Testing with external integrations is extremely problematic. Most APIs have limits, at least the good ones that I've worked on actually have limits, so you're only allowed so many calls per hour, per day, per minute, per month, etc., right? So continuously hitting these services over and over and over again to get your data can be problematic. When you're dealing with like private integrations and other company integrations that aren't your big Uber, Facebook, Twitter, etc., I found that there's relatively few sandbox and test environments out there. This is kind of an age-old problem with the way that enterprise software is typically built, but I've worked on a number of systems where sandbox environments weren't built, they didn't have sandbox, we couldn't access it, we needed to go through extra steps to get it, so it makes it very difficult because you're actually testing against production data. If you're dealing with anything that's touching consumer data or PII of any sort, this can obviously be a large problem. You don't want to pull that data in, you don't want to actually affect change in a production environment. So integration tests are usually run in the build and deploy process. So modern CI and CD pipelines have integration tests as a part of their test suite that they run. You can run this multiple times per day. If you've got multiple developers working on the same project, you're going to be hitting something multiple times a day. Deployments, if you're up in a continuous delivery environment, which I hope you are, if you have external dependencies and you're actually writing tests against them like you hopefully are, your deployments can then be gated by somebody else's service, because if those services are failing or those dependencies are failing, your service isn't going to deploy. So Pact brings a way to kind of mitigate this and sidestep this problem. Speed of external API calls can be a huge problem. Load on external server. I mean, any of these issues are things that I've run into on a fairly regular basis when integrating with other partners. And one of my favorite ones is ongoing development can create fragile environments. So know about you guys, but I break tests pretty often. Thankfully, I don't break production very often, but a lot of times when you've got a lot of people working on something and they're pushing things up, test is going to go down, sandbox are going to go down. If you are integrated with a partner and their test environment's down, or they're doing deploys, or it takes them all day to do a deployment in some cases, your project's going to slow down, right? Your rate of development's going to slow down, your deployment's going to slow down. So these are just problems with external dependencies. So enter Pact, and Pact to the rescue. So Pact at its core is basically a contract tool. It allows you to build contracts that can be shared. There are providers and consumers that cover both sides of an integration. So if I'm a consuming partner and I'm going to be integrating with another provider, they can essentially build a pact that says, here's how this is going to work. When you call this endpoint, when you call this method, this is what you're going to get back. It allows you to replace actual external API calls with basically a service that you can run on the framework. Bundled and distributed, this means that the Pact files, once you actually have them, you can actually publish them out to a Pact broker. It's stored in a JSON file. You can edit it as you wish. You can distribute it. You can email it. There's a lot of ways that you can get these into different people's hands. And one of my favorite things about it is it's language agnostic, which means that if I'm writing .NET to consume a service, to consume data, I don't need to worry about how it's implemented at all, right? I don't need to worry about how an API is going to be serving it. If I'm writing the API, I don't need to worry about whether you consume it in Ruby or .NET or Java or XYZ, right? It's language agnostic because at the end of the day, we're mocking an external API. So some quick verbiage, producers and consumers. Producers responsible for serving the contract. I like to think of this as the external API. These usually end up mocked during your test. In the case that we're going to be looking at in the example, we essentially create a new web application that mocks up the way it makes API calls and consumes the data. The consumer is going to be responsible for integrating the contract. I like to think of this as my system or as a system that you're working on. So if you think about Twitter being the API client, you can create a contract that has a tweet feed, right? And then you can actually go ahead and build your consumer to consume that tweet feed in your system so you can run your test and everything along those lines. So as far as building a pact, it's fairly straightforward. Their documents and their tutorials online are fantastic. You start with your Pact package. So if you're working on .NET, it's PactNet. If you're working on Ruby or Rails, that's where this is actually based. They've got gems for that. They've got plugins for JavaScript and Node and everything else. So you want to install the relevant package. I started with the consumer. Basically wrote a consumer that said I expect my data to match this schema, and I expect my results to look like this. Build and run my test, which generates the Pact file, and then I went ahead and built the producer. So the producer is going to be what's serving the data, in this case the API. And then you import your Pact, and once you're done with that, develop against it. And over here on the right, we have a quick example of what a Pact looks like. So you name your consumer, you name your provider. In this case, I just named it pretty simple, PactNet consumer, PactNet provider. And then from here, you list out your interactions. And this is where your Pact file will really shine. So you give a description of what your specific call is going to be. You give it a provider state. And then you make your request. You pass in methods, your path, query string parameters, bodies, anything along those lines. And then you say, with this request, I expect a response that looks like this. And in this case, we've got a request that is a get method for a specific path, API user /0. Once I serve this data or consume this data, I expect my response to look like this. It's a 200 response. It's got a header. It has a body attached, etc. And your Pact file is going to be a large JSON file that looks like this, and it just describes what your interactions look like. It doesn't have to be JSON. You can do YAML if you prefer. I tend to be just a bigger fan of JSON because it's a little easier to read. So with that, I say let's jump in and take a look at some sample code. So I'm going to introduce that here. So I'm working in .NET Core, and I'm working on Mac and VS Code. So I'm going to start by showing kind of the producer side of this, and then I'll show the consumer side of this. So in this service, in this project, I have a real simple API. I have a single controller. It's called a user controller. All it does is essentially makes a call to a service that I've implemented. That service does some work and returns some data. And in our case, I will show you exactly what that looks like. So I've got this user service here. It's got this public method that's exposed called get. Takes in an ID. This ID is configurable for just the testing purposes. And then it returns a small object back to the controller. Right? So the idea is that I have this API that's going to serve some data out. In this case, I have a user that I'm going to serve. My user model is pretty simple, pretty straightforward. I got an ID, a name, occupation, a couple roles, just to show a little bit more complexity here. So this is it, right? This is pretty standard web app, pretty standard application controller. I could have integrated against essentially any API service, and I thought about doing integrating with like Twitter or Facebook as an example, but wanted to show kind of how easy it was to actually get this up and running. From here, I went ahead and wrote some tests. My library is where my user service lives, and I have a test project down here that is going to test this. So my producer test looks something a little like this. And how this works in .NET, Pact essentially is going to, when it's testing your API, it's going to load the Pact file that you have that's either generated or constructed by hand or emailed to you from a third party. It's going to load the Pact file, it's going to bootstrap the API, and then it's going to verify that your API is serving data against the Pact appropriately. So there's some boilerplate code that you have to write to make this work. I'm not going to go through that in detail. The documentation is pretty thorough in how to set that up. You can also check out my GitHub to see some of that boilerplate if you'd like. But the actual test looks something along these lines. So we load up basically a custom implementation to output data onto the command line so we can actually read and see what's going on here. But then the actual test is this guy. So this is a Pact verifier. So this is a class in Pact.NET. We load up the provider. We basically say that our service provider is this application, which is bootstrapped and currently running on a specific port, so localhost 5000. It honors the Pact with my consumer. So if I looked at my Pact file, so working with my provider, and I say it's got a Pact with my consumer. So we, with a nice fluent DSL syntax, we say, hey, we're going to honor a Pact with my consumer. I pass in my URI for the Pact, so basically my JSON file representing the Pact, and then I verify. And that's it. Testing the provider is pretty simple. And essentially what this is doing is it's going to create a mock version of your API. It's going to stand up those endpoints, and it's going to make the calls that are actually in the Pact, and it's actually going to run and verify that your API is serving the data in the schema and the format with the specifics that you're looking for. So from here, if I go ahead and run a test, this is going to build. Again, this is all in VS Code. Ignore my warnings. And we've got a passing test. So essentially what this did again, open up the API, make a call against the API, which we can see here because I had the API actually running, makes a call against the API, returns the data and compares the schema, the response, the headers, the JSON, the entire response against what the Pact is supposed to be serving. So that's the producer side, which once you kind of get the boilerplate written, it's a little easier to work with. Now, this doesn't have to be .NET. It doesn't have to be a .NET API. I thought very long and hard yesterday about actually writing an Express app just to go ahead and serve this to show that as an example. I decided I didn't want the additional headache on a Sunday afternoon. So it's pretty straightforward, pretty easy to work, and I can be sure that the data that I'm serving to my clients and to the people that are going to be integrating with my service are getting the data that I told them they were going to, which means that they can now, in isolation, integrate and consume the data on their own with no additional dependencies from my system. So with that, let's take a look at the consumer test side of this. So the consumer test, this is essentially a service that is going to make a call to the API to load that data, to load that schema, and to make sure that this is actually building models appropriately and implementing your business logic appropriately. So we have a test. We're expecting our user to look essentially like what we have, and then very similar to our Bootstrap that we have for the producer test, we have a mock service, and I'll take a look and kind of show you what this looks like here in a second. Given some criteria, we want to say when we receive a specific request, define our method, define our path, and what we expect it to respond with. And then we want to make sure that this actually honors the Pact itself. So once we do all that, we make this call down here to verify interactions to make sure that we actually loaded the Pact file, that it actually matches with what we're looking at. So the service that I actually ended up implementing so in here I have this PactNet client, and at its base it's just a real simple HTTP client. When you're calling external dependencies and external libraries in .NET, this is a pretty common way to do that. We essentially create an HTTP client, make a call to the API, pass in our ID, and then we serialize our data if everything looks good. And in our case, we're just going to call our actual API in this one. But you could very easily see this being a Twitter API, a Facebook API, an external dependency. So I have this client, and then we have to create a fixture. Fixtures in XUnit are reusable, injected classes that can be shared across multiple tests. So a lot of times when you're doing tests, you want to run everything in a single instance. So one test is one isolated instance. You're creating classes, you're creating state, and it's isolated to that. In this case, a fixture just gives us the capability to share. Essentially what I'm doing is creating a mock server for Pact that's basically saying listen on localhost, in this case port 9222, and then once I get data from there, just go ahead and respond with my Pact. And this is built on dispose, which is how we actually generated the Pact to begin with. You can generate the Pact on either the producer side or the consumer side. It doesn't really make a difference. You can build it on your own. Their schema is well documented online. Or somebody emails it to you. Instead of building it here, you can just go ahead and consume it. All right. So from there, we go back to our tests. So we've got our mock service, which is basically essentially a mock HTTP service that overrides the client that we had implemented that's going to be spun up and run on port 9222. When it gets this request, it is expecting certain results, and we can verify all that. So if I go up here and I go ahead and run this test, hopefully this passes. And it should tell us that the client that we built that's consuming the data, that is serializing the data, matches what the expected pact is from the service itself. So we've got it passing, so everything is good. So that's about all I have for the code demo. As far as how this all works. I try to keep it pretty high level just because I know this can be pretty complicated. And I'm not a big fan of doing like live coding demos. In fact, I have a couple rules for speaking, and one of them is no live coding demos because they never work out properly, but that's just myself. So with that, I am pretty much good. So let's open up to some questions. Dave.
So you said you had a bullet of your morning slides where they often said Pact replaces the actual API calls. I think I know the answer, but I want to make sure. So does that mean that I have do I have to take a dependency in my production code on Pact? Like if I wanted to remove Pact later, then does that mean that it's one of the folks away from it and change the way it's behind it, right?
Yeah, that's a great question. So the question was, essentially, how do we go to production without having Pact implemented into our production code base? Is that a good summary of that?
Yeah, or if I wanted to rotate it away to the newer framework.
Right. And talking about dependencies with Pact itself, right? So when you're creating the Pact, so if you create your producer, you create your client, et cetera, you don't technically have to implement this inside your production code. The service that I mocked up is actually isolated in my test project. So when I built the Pact consumer service, which is basically taking the API and bootstrapping it and kind of creating its own little mock service, it's isolated in the test code. So if you pull it out at some point, it's not going to break anything. Now, the actual client that is implemented that is going to consume the data, that is actually implemented in one of my library projects. That would be something I want to deploy. But again, all that client is really doing is it's grabbing the data from a specific API port or URL and mapping it into a specific model. So let me show you, because I'm a big fan of code. Okay. So in this guy, so this is the client that I have, and it's basically a simple wrapper. It's just a HTTP client that's making a GET call. All it's essentially doing is it's taking a URL, a new URI, and making a call to API user, and then passing in some parameters. If everything looks good, it then takes that data that we get back, that content that's being passed down, deserializing it into a user object and returning it out of the client. So the idea here is if you have a service that is at some point going to implement the user, right? It's going to use that user object. It's going to use that data that's coming back from the client to do some type of domain or business logic. So all of this is doing is basically saying, go and get the data, take that JSON, convert it into a strongly typed model that I can use in .NET, and then you can do something with it. In order to actually make this work, and so I'm not actually making a call to that client, is where we are creating essentially a mock service. So what this is doing is we have a mock service provider, and this is a class that's provided by Pact. We're passing it an address, basically a URL, so localhost 9222 in this case. And we're saying, go ahead and build a service that runs. And if you look through the code, because Pact is open source, you can take a look through it and dig into the weeds. It's essentially creating an HTTP service that is, instead of loading data from a database or from any other source, it's just loading from the Pact JSON itself. So this can live completely isolated in its own library. It can live in the test project. It can live wherever you want it to. So it does not have to touch your actual production code base.
Okay.
Cool. Good question. Any other questions? Yes, sir?
How do you go about generating facts? That dispose?
Yes. Yeah, sort of. So the question was, how do you go about generating the pact? So in this case, with the way that I built this project, I actually started with the consumer because I thought it was a little easier to work. Anytime that you're running with this pact builder in .NET, you can call the pactbuilder.build at any point in time. I put it in the dispose because this fixture is only disposed of after all of the tests in the test suite have run. So if I wanted to test multiple packs and things like that, we can put it here. Ideally, your pact is actually built with you and whomever your integration partner is at the point in time. Because it's a standard schema, there's a standard format to it. The idea is you can sit down, you and a person from Twitter, right, can sit down and say, when I make this call, I expect this data to come back. When I make this call, I expect this data to come back. Or they can essentially take like a Swagger file or any other API document file, and you can convert it into a pact and say, when you call this endpoint, you get this schema back. And the whole idea there is to make sure that kind of everybody's on the same page. But in the .NET world, all you have to do is call this pactbuilder.build, and it will output that pact file for you. Good question. Anybody else? Twitch? Nothing from there? We're good? Okay. Fantastic. Well, that's all I have. I'll be around afterwards if you guys, if anybody has any other questions or just wants to talk test or .NET or anything else, I'm happy to do so. All right. Thanks for having me.